Okay, welcome to the last part of longitude and latitude. That's the subtopic is shortest distance between 2 points on the Earth's surface. What if I tell you that the shortest distance between 2 points on the Earth's surface is the distance along the Great Circle? So I'm saying that the shortest distance between 2 points on the Earth's surface is the distance along the Great Circle. That's distance along the longitude. And you might ask a question, why are we now talking about the shortest distance? Or you might be confused. You assume that we've done distance along the longitude. Yes, this part is very important, because here in most questions you might be given a common latitude, which is now the distance along the latitude, and you might be asked to find the shortest distance between the 2 points. That's, you are given 2 points along the same latitude and different longitudes, and you are now asked to find the shortest distance between the two. I'm here to tell you that the shortest distance is the distance along the longitudes, and I'm going to prove it now. So assuming you have this diagram, we are given 2 points. Assuming you are given that you are given 2 points with latitude 60 and longitude 20, and latitude 60 and longitude 30, and we're asked to find the shortest distance between E and C. I'm here to tell you that the shortest distance is the distance along this longitude. Yes, instead of latitude. I'm going to prove it. So I'll derive a formula for that, and we solve questions. That's, I will solve the normal distance along the latitude. We now compare the distance that we'll get along the longitude to know which one is shorter. So this is the diagram, because for us to find the distance along the longitude, we need to connect the radius of the Earth. That's the radius of longitude, which is the big circle. That's it. So that's, you see the center of the globe. This is the radius from E. This is E to C. So why the center here is this O subscript 1. Why the radius of the small circle is R. That's the R. So as you can see the axis, and maybe this is the North Pole here. So we just copied this from here so that you can picture what is happening. So as you can see, we know that the common latitude here is 60. So let's take the common latitude here, assuming this is a complete. The common latitude, let's take it to be 5. That's, in this case, is 60. And we know that when we are to find the distance between these two, the angle here is 20, while here is 30. So if we take the total angle, here is now 20 plus 30. So let's take the total angle to be theta. So connecting this perpendicular, divide this into theta over 2. Y theta over 2. Theta is our angular difference. Theta is our angular difference. And the same thing, this bisect this angle. Let's call this beta. Here is now beta over 2. Beta over 2. Because we want to get the distance now along this path. So we're going to use this angle instead of this, but we're going to use this to get this. So do you get the logic? I'm saying that we are formally, you'll be given the longitudes, the angular difference here in terms of longitude, but the actual angle, because we are to find the distance now along this, we're not going to use this. What we're going to use is this angle. And this line, our axis, bisect it into two. So our main aim is to find the angular difference here now, which is beta. So we'll start. You notice that if we connect E to C, we have a chord because this is an arc. So if you connect E to C, we have a chord. And we know that a chord, okay, so I'm saying that in triangle OEC, that's O subscript EC, OEC. The chord, which is EC, is, remember the formula for chord, length of chord is 2r sine theta over 2. You get the logic. The chord, if you could remember, in our circle geometry, the length of chord. So this length in terms of this triangle OE, that's O subscript 1 EC. This length of chord is 2r small r sine half theta. And we know that small r in terms of big R is 2r cos phi, where phi is the common latitude, sine theta over 2. So that's the first thing. If we come to the other triangle, that's triangle, the bigger one, triangle OEC, we can still get the length of chord because it's a chord. So see our arc here now. So the chord EC. So in triangle OEC, we know that EC again is now 2r sine beta over 2. So you can see, if you could remember from our basic circle geometry. So let's now connect the two. EC is this, and that same, okay, let's call this equation 1, this equation 2. So what do you observe? You notice that 2r cos phi sine theta over 2 will be equal to, okay, let me just remove this, will be equal to 2r sine beta over 2. So our main aim is to find beta because we are not giving beta, we are giving theta. From this, theta is just the angular difference here, which is in this case is 20 plus 30. But we use theta to represent that, and since this is a perpendicular bisector, so it bisects the angle. So let's find beta. So 2r. So I have cos phi sine theta over 2 equals to sine beta over 2. So we divided both sides by 2r. So making beta the subject of formula, remember this is beta over 2. So this is beta over 2 arc sine of, or sine inverse of, cos phi sine theta over 2. Which implies that making beta the subject of formula now, beta is now 2 sine in arc sine of cos phi sine theta over 2. So this is now our angular difference. Therefore, the distance now along we've gotten this angle now, so we'll find our normal distance, which is the distance along this longitude, this length of arc. Therefore, the distance along the longitude, which is the shortest distance. Therefore, the shortest distance between 2 points on the Earth's surface is now equal to beta. Remember, beta over what? Over 360 times 2 pi big R. But beta, we've derived that beta in terms of file and to 2 arc sine of cos phi sine theta over 2 over 360 times 2 pi r. So we can still simplify down to, so we can now simplify so that's the distance, the shortest distance is now, I said, is 2 arc sine of cos phi sine theta over 2 over 360 times 2 pi r. So we can reduce 2, so 2 times 2 is 4, so 4 in that is 90. So I have arc sine of cos phi sine theta over 2 pi r over 90 degrees. So this is the shortest distance between 2 points on the Earth's surface. We'll prove that by solving. I will solve this question using the normal distance along the latitude, and after we now use this formula. Okay, remember where we didn't describe before, where phi is the common latitude and theta is the angular difference, as the angular difference between the longitude. So let's solve. So let me copy the equation. So we want to solve this now. We want to find the distance between E and C in terms of latitude, distance along the latitude, and after we now solve along the longitude to know the distance, which one is shorter. So we know that the distance EC along the latitude, we've known that this. So if we connect, okay, let me just connect so that if we connect, this is the center. If we connect this is small r, this small r, our angle here is 20, while the angle here is 30. So our angular difference is 20 plus 30. So you have 20 plus 30 degrees over 360 times 2 pi 22 over 7 times small r, and we know that small r is big R, which is 6,400, cos phi is 60 degrees. So we have 50 over 36, which is 5 over 36 times 2 times 22 over 7 times 6,400 times half. Think something, this gone, this gone. So we have 2 here, so we have 5 times 2 here is 11 times 6,400 over 2 here is 18, so 18 times 7. Do you get? This is off. 2 here 11, that's the 11. 2 here is 18, that's 18. So let's calculate those. This times 11 times 6,400 divided by 18 times 7. So we have 2,793 793.65 kilometer. So that's the distance. In terms of the latitude, that's along the latitude. So let's find, because our main idea is to show that the distance along this longitude is the shortest distance. So using this formula now, so let's substitute. As you can see from the equation, EC arc sine of cos 60 degrees, because that's the common latitude, sine our theta. Remember, theta is the angular difference, which is 20 plus 30 over 2. So times pi, which is 22 over 7, times 6,400 over 90. So let's calculate. Cos 60 is half. Okay, maybe let's. Okay, we continue. Okay, this is arc sine of half. That is 50, 25. So I have sine 25 over 2, because cos 60 is half. So this 50 over 2, 25. So sine 25 over 2 times 22 times 6,400 over 90 times 7. Okay, so let's solve. So I have shift sine bracket sine 25 over 2. So that's 25 divided by 2. So whatever that I get times 22 times 6,400 is equal to this divided by 90 times that, which is 630. So I have 2,726.39. 2,726.398. So let's compare the two distances. So I say that the shortest distance now is 2,726.398. So let's check the previous one. The previous one was 2,793. Okay, let me just approximate so that you can easily. This is approximately 2,794 to the nearest kilometer. So why this is 2,726 kilometer. So what do you know? I think this is smaller than the previous one. The previous one is 2,794, but this shortest one is 2,726. So I've proved that the shortest distance is this. So question will come like that. They will give you the distance along the latitude, but they will ask you to find the shortest distance. So you have to use this formula. You have to use this. So I've proved it's a very important formula. But thank you.